Now, one thing we can do once we've figured out what it is we want to study and looked at our population and taken a representative sample and then collected data from that representative sample, be it numerical or categorical, we need a way to visualize this data. And visualizing data is really important because it's a lot easier for the reader or our audience, the ones who want to see this data, to take a look at, right? If I just threw a whole bunch of numbers into you in a paper, that wouldn't be as good as, say, a graph in a magazine, right? So we need to be sure we know how to visualize our data. So the distribution of the variable we're looking at, right? For example, it could be eye color, it could be height, refers to the way the values are spread over all possible values. And we can summarize this distribution with a table or a graph, and we're going to make both coming up real soon. So some important things to know when we're making a graph. So the first thing, our graph needs to have a title. This is number one key for making a good graph, right? That title explains what's being showed. I am showing the heights of freshmen in statistics courses, right? You have to be very, very specific. Next, I need to label my vertical scale, right? That's our y-axis. Goes up and down, right? I need to label my vertical scale. So it could be height. It could be age. That's going to typically have the frequency value, which we'll talk about in a minute. All right, now we have it written down. Next thing we need to do is we also need to include an axis title that describes the variable. Okay, so if it's, say, frequency of heights or frequency of eye color, that means how often does that eye color occur. And we're going to talk about that in just a second. We have to do the same thing for our horizontal scale. That's our x-axis, right? This is typically where we would have the categories show up or the ages, but our y-axis should be the frequencies. And you need to give this a title as well because it's important. Last but not least, if you're putting multiple data sets on a graph, and that's something you're typically going to see in newspapers and especially with the COVID-19 data that's being shared, right? You need a legend. And the legend tells you how to tell the different data sets apart. Typically, they're different colors, but I need a key because I don't know which color represents what population. A bar graph is the simplest way for us to picture a distribution. Bar graphs are used for categorical data. Remember, categorical data breaks us up into categories. That could be eye color, class standing, ethnicity. Those are different types of categorical data. And each bar represents the frequency, or relative frequency, we'll talk about that in a second, of one category. So how often does that class occur? So let's take a look at an example. So here I have a frequency table for a set of essay grades. So I have 25 students in my class, and I had 4 get A's, 7 get B's, 9 get C's, 3 get D's, and 2 get F's. Okay? This is an example of a frequency table. I'm marking the frequency of how often each letter grade occurred. Now, we've converted these grades to letters. That makes it categorical data. If we'd left them as numbers, it would have been numerical data. So let's go ahead and create a bar graph from this data. So I have to have my y-axis, my x-axis, and we have to come up with a title. How about we do frequency of essay grades? They tend to be kind of long. They're not very creative. I've got my x-axis. This is going to be the grades that the students have. I've got my y-axis. This is going to be the frequency of the grades occurring. I should mark my scale. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. And my grades were A, B, C, D. I almost wrote E, F. Okay? Now what's unique about bar graphs is there's going to be a gap between each of the bars. I don't know if I mentioned that, but because they're typically categories, like in grades, there's an order, right? You think A, B, C, D, E, but if I was doing eye color, there's really no order to eye color, right? Like you can't say blue eyes are better than green eyes or brown eyes are better than yellow. And you could have yellow. I meant brown. Oh my gosh. So there's no like hierarchical structure. So what we do is we always would leave a gap between our bars. So here I've got 4 A's occurring. I've got 7 B's. And see how I'm leaving a space? That's a common thing for a bar graph. If they don't have a space, there's something else, which we'll talk about later. I had 9 C's, and it went up into my title, but that's okay because this is just an example. I had 3 D's, and I had 2 F's. And what's nice about this is opposed to looking at this table, so we'll look at the table. If I'm trying to figure out what was the most commonly occurring grade, I have to go like down frequency by frequency. If I look at this graph, I can just be like, oh, look, this is the tallest bar. Oh, it corresponds to C. And then I can see what the most frequently occurring grade was, or commonly occurring grade.